Hello everyone, this is Vasant, a 9-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve a problem on fluid mechanics from the midsem paper of IIT Bombay. So in previous lectures, we already solved these problems. Today we are going to solve the last problem of this paper. So this is the last problem. Here read a 20 centimeter diameter pipe takes a 180-degree turn in a horizontal plane. Means it is in a horizontal plane. So the two pressure gauges at sections 1 and 2 record pressures of 9500 Newton per meter square and 7500 Newton per meter square. And head loss in the bend is given, that is 0.3 B square by 2G. Find the flow velocity at section 2. Find the magnitude of the force acting on the pipe bend along the x-axis, and third part is resultant force on the bend, pipe bend. Okay, let us solve the first part. So first part. To take these two cross sections, this is 1 and this is 2. So whatever fluid entering in this section, that should leave in this section, because fluid is incompressible from continuity or conservation of mass. From conservation of mass, A1 V1 will be is equals to A2 V2, right? But A1 A2 is equal, so V1 will be is equals to V2, as A1 is equals to A2. So let us assume V1 is equals to V2 is equals to some value of velocity V. Okay. So we can apply Bernoulli's theorem between section 1 and section 2. At section 1, that is P1 by rho G plus half rho V square will be is equals to, at section 2, P2 by rho G plus half rho divided by G plus V square divided by G, right? Plus the loss. Loss is given by 0.3 V square divided by 2. Okay. So this one gets cancelled. So P1 minus P2 divided by rho will be is equals to 0.3 V square by 2. So V square will be is equals to 2 into P1 minus P2 divided by 0.3 rho. So we already know the value of P1, that is 9,500, minus value of P2 is 7,500, divided by, this is 0.3, and rho of water is 1000. So we get 2 into 1000 divided by 0.3 into 1000. Okay. So we get V square is equals to 40 divided by 3. So V will be equals to under root 40 divided by 3 meter per second. So let us calculate this value. Under root 40 divided by 3, that is giving V is equals to 3.65 meter per second. So this is the answer for first part. So second part is find the magnitude of the force acting on the pipe bend along the axis. So we need to apply Reynolds transport theorem. The Reynolds transport theorem for conservation of mass is given by force on control volume will be is equals to dou by dou t integral control volume rho V bar dV plus integral control surface rho V bar to V bar dot N bar dot dA, right? So here our control volume is this one. Let us take the control volume as shape of the tube. This is the control volume. So this control volume, our control volume is non-deformable, right? And stationary. So this will be 0. So we got F bar dot CV will be is equals to rho into integral C S V bar dot N cap into into dA, right? So now if you observe the control volume, perpendicular to this control volume here, the velocity is 0. In this region also perpendicular to the control volume, the velocity will be 0. In this region also perpendicular to the control volume, the velocity is 0. So here also perpendicular to the control volume, the velocity will be 0. So the only place where the velocity perpendicular to the control volume is non-zero is here and here, right? Here the velocity is in this direction with value v, the velocity is in this direction with value v. So we get this value as rho into, at this place, at place 1, the value will be v into 1, right? So n cap will be 1, I cap cancels, so this will be v into 1. Plus the value at 2 will be, so this will be I cap, right? So this will be v I cap, the velocity is in negative x direction, to minus v I cap dot minus I cap, right? So we get f bar dot cv will be is equals to rho into area will also be there, right? So a into v square I cap plus v square I cap. So we get 2 rho a v square I cap, right? So f bar will be fx I cap plus fy j cap. That will be is equals to 2 rho a v square I cap. So fx will be is equals to 2 rho a v square and fy will be is equals to 0. So let us calculate fx. That will be is equals to 2 into 1000 into area. Area is pi by 4 d square. So d is 0.2 square into velocity is 3.65 square. So this is fx. This is the answer for second part. For third part, they asked for resultant force. Here the resultant force is also fx because fy is 0. So fr will be is equals to fx. So that also will be is equals to 2 rho a v square. Right? So that will be equals to 2 into 1000 to area pi by 4 into d square 0.2 square into 3.65 whole square newtons. Right? If we put it in calculator, we get 2.265 divided by 4. 2.265. We get the answer fr will be is equals to 1 point something value, some newtons, okay, nearly 1. So this value will also nearly 1.3 I think so, newtons, okay. So with this we completed the midsem paper of fluid mechanics of IIT Bombay. With this we end today's lecture. Thank you.